plugging the numbers in for the y.
Yeah, very good.
You solved it.
So if y is 8 and x is -3.
And you multiply -3 on both sides.
Very
and
good.
You get the answer for A.
Jake's very good at solving equations.
And you gotta go back and plug that in for A, and you got your answer.
Yeah, so it becomes y equals -24 over x. That is our equation.
He has a very good
You have
critical
your math
thinking
brain.
brain. He
Yeah.
just
You have
doesn't
your
like to
math
do the
brain
crap
on
that is
today.
useless, which makes
You were
sense.
like, he was very mathy in personal finance. He was doing all the math.
I love it.
Just simple numbers, that's it. That's all I can say.
I love it.
Okay. You're high maintenance, you know that?
Okay.
He throws things and you're like, go pick it for me.
Wow.
Oh, she broke the cycle. Proud of you.
How dare you? How dare you pick it up for yourself?
It's okay to be high maintenance.
Thank you. There we go.
That's
It's back.
funny. It's back.
I couldn't get it after I broke down. Couldn't be patient. See, that's the other thing.
All right.
A little bit.
We're just gonna do a brief little 8.2 cute, like
No, none of this is cute.
just a little,
You're cute, Renshaw.
just a
Jakey
little,
stuff.
Yeah, you
Hey, I'm
are.
just giving you a compliment,
just
man.
a little look see at 8.2.
Uh-oh.
He is actually excessive. Add an S.
Yes, very much so.
Well, today is the last day of learning.
Why would we stop learning? We have we do not need to review for 2 weeks for the final
Yes.
exam.
Actually, we might.
We're
We
only
might.
required to review for 3 days. Graphing.
Yeah, or more.
Y'all don't even, not y'all, some of you, don't even use 1 day of review when I give it to you.
Me?
Some people don't use any days.
No, that's me.
Funky.
Is that what this is? Functions? Yes, functions.
No.
Function's bad.
So remember I said we've got all our different functions. Remember we had exponential. Okay, so exponential is this,
Oh boy.
and it's like shoo, like this. And there's an asymptote in exponential. And where is that?
Y equals
The
1.
line where the line doesn't.
Oh,
Yeah, the line where the, and so in the parent function that is actually the x-axis. But it is possible if you had +2 or something like that at the end of this, it could move up, but it's a horizontal asymptote, okay? So there's an asymptote going this way that your line does not cross. Okay. Then we had logarithmic, so y equals log base b of x, okay? Logarithmic goes like this, or like, wait, see if I can do it, just like this, and it has a vertical asymptote. It doesn't cross the parent function, the basic one, it doesn't cross the y-axis, so it's like, shoo, and it, let me make sure, oh wait, I don't wanna, this looks a lot like the log one, I don't wanna mess you up, hold on.
Yes, you
I
do.
probably should have just drawn one of those. Let me just take that out and just draw one.
J.Brown, you take joy in us suffering. I don't even want to hear it.
I don't. I genuinely don't.
That's why Unit 7 is your favorite? Definitely.
I see the words domain, range, asymptote, and long division. So
Well, no, the last year's Unit 7.
Oh boy.
Last year was geometry.
I'm not.
Well, the
Sorry,
year
I'm not
before
gonna
that's
draw
it,
two
Jake.
of
I
these.
meant
Let me just
last
draw
math
one.
year.
I think drawing two is
Algebra
gonna
year.
confuse you with what we're doing.
Algebra
Alright.
1.
So we've got a vertical asymptote for logarithmic. Then
Okay.
for this one, rational functions will be y equals 1 over x. This is the one that has the 2, because then it's gonna make that look too similar.
Oh no.
Oh, that's gay.
Which one's this called?
There we go. This is the rational, the one we're studying. So you have 2 sides to it, phew, and it has a asymptote going down the middle. This value of x right here, what does x equal along the y-axis?
0.
0. Looking at this equation, do you guys know why x cannot equal 0?
Because
Because
it,
neither of those are gonna hit 0.
You're right, it won't, but like, looking at the equation, why
It
could
would
we
be-
not plug in x 0?
because then you'd have infinite.
Oh.
The fraction would be 1 over nothing, which is
Yes.
either
Yes.
infinite or nothing.
If you know that rule, you can't have 0 in the bottom of a fraction, or the world will explode. This, it's not possible.
It's
I
another
can't.
one of those stupid ones that it's like,
Yeah.
is it real? No.
I
but
can't
can
divide
we?
by
No.
0 ever. You can have 0
I hate
in the
math.
numerator, but you can't divide by 0 ever. So it's impossible to have 0 in the bottom of this fraction. So whatever makes this 0, that will be the value of x where your asymptote is.
Well, yippee.
Okay.
0 divided by 0 makes a black hole that destroys
Yeah,
the universe.
yes. So if I had y equals 1 over x plus 1, what would be the value of x that would make this equal 0?
-1.
Yes, very good. So that means the asymptote is at -1. So the asymptote would have moved to right here, okay? And then you have your, oh, how do I do it? See if I can do it right. I can't ever draw these
So
without
the
actually.
asymptote is -1.
Yes, so for this, in this case, the asymptote is now shifted to the left, and you can kind of see that as like a horizontal translation, right?
No.
So now the asymptote is here.
X equals -1. Oh, no.
Huh?
Why is it -1?
Because -1 is what would make this equal 0, and we cannot have this equal 0. So -1 is the only thing that's not in the domain. So if you were to ask, what is the domain, and we do not want this to equal 0, so if we were to solve this, so x cannot equal -1. The domain of this is, you could say it's all real numbers except x equals -1. Or you could say, do you guys remember way back, I think long ago,
Oh wait, so X
Long
equals
ago.
long ago in chapter 1, the very first lesson we learned in here, do you remember this? Oh, x such that,
Oh no!
Why?
Kill me.
No. This is what killed my grade last time.
I'm not making you do this, but I'm just telling you, you can represent domain with step builder notation. You could say, so x such
Oh, I
that
missed that.
x does not equal -1. You could say it goes from -infinity to -1. It doesn't actually touch -1. So you could represent it
So-
like that. You could say all real numbers except -1. Just
Miss
different
Brown,
ways
so
to.
like why is it why? So if X cannot equal -1, then why is the asymptote -1?
The asymptote is an invisible line that your graph does not touch.
Okay.
So this isn't part of my, so this is my graph, and it will touch everything except this line.
But it also so then
Really
X
close
won't
to
equal
it.
-1.
Yes, x will never, in my graph, will never equal
So in graph
-1.
X won't equal -1, but the asymptote is
Is it?
X.
Yes, if you wanted to say
-1.
what is this line, it's x equals -1.
Okay. Interesting.
Is there gonna be a bunch of graphing on this that we're gonna have to
No,
do?
I'm
Yay.
just getting you familiar with it. I may have y'all
No,
just
no.
plug in.
We're familiar with it. We're good. We're all good.
What did we agree the note card size was for the exam?
Huh?
What did we agree that
A
the
page.
a page?
Yeah, a page,
Yeah.
front and back.
Good deal.
Or just.
No, I'm not saying that we can't do this. I'm just saying that we don't need any more work because we have 18,000 things.
This weekend is going to suck.
Yeah.
So let me show you
Grandma,
show you a couple pictures of some graphs that have shifted there.
you should spare us a homework this weekend.
I should spare you. Yeah, I'm not sure. I'm not gonna give you a homework.
Good deal.
That's why I'm just going over some stuff.
I would
we
not.
have-
I would
We
not
have.
do it.
Let me see where we are with grades actually, just to double check, make sure we're good. 1, 2, 3,
I have 7 freaking papers to write.
7, 8, and I think I have still more to plug in. As long as I have 10 grades for the quarter, that's usually enough. We'll probably have like,
Participation.
we'll have plenty. We'll have plenty. Okay. So these work, the transformations are the same idea for these as they were for every other graph, okay? So looking here at these ones, if you have +1 at the end, what do you think that does to the graph? Shifts it up, right? Yeah, good. So that means that asymptote, oh my bad, oh gosh, it's been so long since I've taught this.
Oh,
Add
no.
to your notes, that's what I was messing up, because please forgive me. That's why I was messing up the log one with the rational. Exponential have a horizontal asymptote. Logarithms have a vertical asymptote. These have 2. And that's what I messed up on there. So add that to your notes, please. These have a vertical and a horizontal.
So what's it called? The rational has.
Yes, the rational function has and I may have drawn it badly. So it shouldn't cross either of these. And I drew it wrong.
So it should have a vertical asymptote.
Vertical asymptote and a horizontal asymptote.
Whoa.
I'm sorry about that. I messed that up. Because, and the reason why, why can't y equal 0 also? Well, think about, so, is there any way to possibly get this? Like, what could you plug in for x to ever make that equal 0? You can't plug in anything, because this number would have to be 0 in order for this to be 0. So, x and y can both not equal 0. They can't equal 0, so y is 0 at the x-axis and x is 0 at the y-axis.
What? It's okay.
No, it's, like the value of y,
Yeah.
like along the x-axis is 0,
Mm-hmm.
and the value of x along the y-axis is 0.
Okay.
So those are your two asymptotes. Now they can move when you do transformations. So here's that's what I was getting to here. So if we move the asymptote up 1, and then, which is this, left or right?
That's
Right.
right.
Right,
No.
it's right. Remember the opposite.
Yeah.
Opposite for these. Yeah. So this would go right 3, 1, 2, 3, and up 1. So this is your new asymptote here. So 3 over and up 1. And then your graph is.
Because it started at the origin.
Yes.
It started on it, but
Yes.
then with that,
It moves your asymptote. Yeah.
I'm gonna write this down, but I don't know how I was gonna write it. What page is that on?
This is page 422.
22?
Yeah, 422. So this one would be A.
420.
Ha.
What?
All right, so 22. Which one?
Uh-huh.
So this is plus 3. So this one moves to the left 3
Slapper.
and up 1.
I don't know what you said, so okay.
So which one of these? This looks like it went 1, 2, 3 to the left and up 1.
Yeah.
So 22 would be C. So this went that direction. Those are your new asymptotes.
This makes me want to see a seppuku.
And I believe what reflection does is it would shoot like that. It would be like that. But none of those show those. Okay, so for 23, so this went to the right 3 and what? Down 1. So
Brownie.
here, huh?
Reflection on axis or rotation are the same thing with these, aren't they? Reflection on a certain.
Yeah,
like-
yeah, I think, yeah.
Okay.
So, yeah. So this one is B? And that would mean this one left 3 and down 1. So this would be D. So just looking over here, let's just scroll over here. Looking at some of these here, what would be the where would be the asymptotes for like
Have it on video.
like this one? Where would the asymptote shift on this one based on this here?
To the left.
To the left too.
We're
So
immature.
the vertical one would stay the same. We didn't go up at all. And then I'm so sorry. The horizontal one would stay the same. because we didn't go up at all.
Oh.
And then we went to the left 2, so that's your new
Oh.
Oh.
and so then it kind of goes around like that. If you had to graph these, right?
Wow.
So for this one, number 16, how did this one shift? If it's x minus 7.
To the right.
To the right.
To the right 7. So
To the right.
the center would move 1,
To
2,
the right,
3,
to
4,
the
5,
right,
6,
to the
7
right.
here. It didn't go up or down. So it's shifted over there. That's the asymptote now. though,
What
so.
would the -2 be on top of however?
Scale.
All
Would that
that's like a stretch or a shrink.
Yeah.
Oh.
Scale.
So it's kind of like you could take this could be -2 times 1 over. Does that make sense?
Okay.
This is like the stretch or shrink.
But for right now, we're just looking on how it moves the asymptote
Yes.
and not the function.
Yeah, because it could be like a lot wider or kind of.
I was gonna say
skinnier,
when
this-
you change the scale or that one,
Uh-huh.
it makes the turn sharper, doesn't it?
Yeah. Uh-huh.
Okay.
Okay, then what about 18? Okay, so how did this asymptote move? If we have +7 down here, which way did it go?
To the left.
To the left 7, so 1, 2, 3, 4,
To the
5,
left.
6, 7. Yeah, so we got one here. And then -5, where did that go? Down 5, good. So 1, 2, 3, 4,
I
5.
also fell down 5.
And then so you have a new one here, and there's your new center.
When I was
So
baby,
it would somehow go, you
that's
know,
why I'm special learning.
something like this.
Special ed.
So it's just kind of shifting that center
Are they always gonna be diagonal from each other?
across from each other. Yes, and some, like I said, they could be these two. If it was like a negative, they could be those two. It could be flipped.
17.
Okay, let's just. I haven't used this in so long. Hold on.
Let's just.
I don't even know where are these things. I could pull up this graph. We can graph just one, just for fun.
It's not fun.
It's
How would you
like
say
you
that?
lied. What are you
How
talking?
would you say that?
I can't even remember. How do I get to the graph paper? Oh, down here.
Down there.
There we go. It's been so long since I even touched this.
Brown's a boomer.
What?
What?
What did you say?
Nothing.
She's talking bad about you behind your back.
It's all in love.
Okay.
I mean, well, not really, but
Let's try to graph. Let's see.
y equals x.
Let's do. Okay.
I can do that one.
We'll do a negative one. We'll do one that's like all of the things.
Yeah.
-3 over x minus 4. I think it said -1.
To the right, to the right, to the right, to the right, to the right.
Okay, so if we were talking transformations, this does everything. This has a reflection, it has a stretch, that's what that number up there would be. It goes down 1 and to the right 4, so all these things are happening. So before we even, yeah. No, that's highlighter. And what?
Bottom left, there you go.
I'm trying to remember how to use this.
That's a thick line.
It is a big line.
Just like
Oh.
Grimshaw.
Before we even,
Gosh, this is just pick on Justin. Good lord.
It's not, it's a compliment.
No.
It very much is.
Justin, we only did it because we love you, bud.
before we even graph it, let's draw our asymptote. So we need to go which way if it's x minus 4?
Right.
Right 4. So 1, 2, 3, 4. So right here, just gonna, no, I want the line. 1, 2, 3, 4.
Am I hitting her?
I'm gonna just like do a dotted line. That is really terrible. I would have been better just drawing it. Okay. There's 1, and then what is -1? Where does that go?
Down.
down 1. Okay, so we're gonna draw. It's like this is the new center of our graph. Okay. Oh, it's so bad. Okay. So if this is the asymptote, it can't cross this, it can't cross this, then we need to pick things on either side of this to try and plug in for our, because Jake, what do we always have to have when we're graphing?
A point.
The points, the chart,
What?
the chart.
Oh,
Bing bong.
what chart?
I
This.
need a
Oh, the T-chart.
Alright, so if this is the center, let's pick some things on this side. So we've got, what is this, 1, 2, and 3? Can we pick those numbers?
Mhm.
1, 2, and 3, let's see how that works. 1, 2, and 3, and then like, so 4, we can't use 4, so we'll also pick like 5, 6, 7.
1, 2, 3, 5, 8, 7. I know how to count.
Alright, if, oh, all this math, okay. Is this a calculator? Alright, plug in 1 here.
Join the dark side, Brownie. Do it.
If I plug in 1 for x, 1 minus 4.
1 minus 1.
Negative 3 over negative 3, that's 1 minus 1, 0.
I just told you that.
You did it. Well, I needed to, my brain was catching up to you.
Is that an admission of defeat? Yes.
Yes.
I win.
So 1, 0 would be right here.
I don't want to do anything.
Alright, and then we plug in 2. Huh?
1 minus 4 is negative 3.
And then negative 3 divided by negative 3 is
0.5, I think.
So was that 1.5 minus 1 is
It would just be 1/2.
0.5.
1/2? Good. Okay, so this is 1/2.
I was right again.
We plug in 3, we get 3 minus 4, which is negative 1.
So negative.
So
there's
positive 3 minus 1 is 2.
Whoa.
Or you could skip all this and do the table.
Yeah. Alright, 2 and 1/2. 3, 2. And if you had wanted to put, I mean, if you wanted to get really exact, you could put some more here, but we are getting pretty close to this line here. And pretty close. Remember, don't ever cross the asymptote. So there's 1. And then this side over here, we've got 5. If we plug in 5, we
2.
get negative 4.
Yes.
Good. Look at you go, Madison.
Yeah.
Thank you. If I plug in 6,
Should get negative 5
which is
That's-
negative 2.
that's a
Whoa.
Oh, is it because I was pushing that
Yes, yes.
in? Ugh.
It doesn't track very well when you do that.
That was cool.
What'd you say?
negative 5 over 2.
Negative 3 over 2. So that's negative 2.5?
What?
You can't read that?
No.
And then if you
So-
do 7, it's negative 2.
6, negative 2.5.
Wait, what about 5 to 4?
Oh, yeah, sorry. 5,
That's what it
negative
is.
1,
5
2,
to
3,
4
4.
is negative 4.
Mm.
5, negative 4. 6, negative 2.5. And then what was 7?
Negative 2.
Negative 2. 7.
Don't make no sense.
And then you can just kind of. See our pretty graph?
Cute.
With our asymptotes. And those are rational functions. The parent function for this, just so you remember,
You skipped 4. You have 1, 2, 3, 5, 6, 7.
why did I skip 4? There's a reason.
I don't know.
The asymptote.
It's the asymptote.
No,
It can't be 4. It's not allowed to equal 4 because that's where our asymptote is. The parent function for these are this. Okay, it's when x is in the denominator of the fraction. That's this kind of graph. We'll give you that.
Cut it. We're done. Cut.
Last thing. Not
No,
of
we're
this. This is a review. So last thing I want to just review.
We're at 25 minutes.
You can turn this off. You don't. This isn't new information.
Okay, good.
What I'm gonna do.